Look up at the night sky. Go ahead, count the stars. 1, 2, 3, 4, 5. How many do you see? Maybe a few hundred if you're in the city with all those streetlights washing out the sky. Maybe more if you're lucky enough to be somewhere dark. On a really perfect night away from city lights out in the countryside or the desert, maybe you can see 2,000 stars. Maybe 3,000 if your eyes are sharp and the sky is absolutely perfect and you give yourself time to let your pupils dilate fully. You think that's a lot of stars. You think you're looking at the universe. You think those points of light scattered across the darkness represent what's out there. You count them, you make constellations out of them, you tell stories about them. Ancient sailors navigated by them. Poets wrote about them. Every human civilization that ever existed looked up at those same stars and thought they were seeing everything. You're not even close. Those stars you see, they're nothing. They're a joke. They're so insignificant compared to what's actually out there that they might as well not exist. If the universe were a book, those visible stars wouldn't even be a single word on a single page. They'd be a single letter. Actually, they'd be a tiny fragment of a single letter. Let me put this in perspective right now before we go any further. Those 3,000 stars you can see on the best night of your life represent approximately 0.00003% of just our own galaxy. Not the universe, our galaxy, the one we live in. You're seeing 0.003% of your own cosmic neighborhood. It's like standing on a street corner in Beijing and thinking you can see all of China because you see 3 people walking past you. It's like looking at 3 grains of sand and thinking you understand the beach. When you really understand how many stars are in the universe, numbers stop working. Your brain stops working. The scale becomes so massive that it's not just big, it's incomprehensible. It's beyond comprehension. The words a lot become meaningless. The word many becomes a joke. Even scientific notation starts to feel inadequate because the numbers we're dealing with are so large that they exist in a space beyond human intuition. Here's what I mean by incomprehensible. You understand 100 things. You can picture 100 people in a room. You understand 1,000 things. You've seen crowds of 1,000 people. You might even be able to grasp 1,000,000 with some effort. It's a stadium full of people, a big city's population. But 1,000,000,000, 1,000,000,000,000, these aren't numbers anymore. They're abstractions. Your brain can read them, but it cannot hold them. It cannot visualize them. They exist only as symbols on paper or pixels on a screen. And we're not talking about billions. We're not even talking about trillions. We're talking about numbers so large that billions become rounding errors. We're talking about numbers where trillions are footnotes. We're talking about a scale that makes every human endeavor look like a child's game with pebbles. But you don't believe me yet. You're thinking, sure, it's a big number. I get it. Lots of stars. You're not taking this seriously because you can't. Your brain won't let you. It's protecting you from the existential weight of what I'm about to show you. Because when you truly grasp the scale of what we're talking about, when you really let it sink in, something breaks inside your understanding of reality. The universe stops being this comforting thing with human-scale problems and becomes something alien and vast and utterly indifferent to everything you've ever known or cared about. Let me show you why. Let me take you on a journey that starts with what you can see, those friendly, familiar stars in the night sky, and ends in a place where numbers lose meaning and the word incomprehensible becomes the only honest description available. This isn't about learning a fun fact. This isn't about saying, wow, that's a big number, and moving on with your day. This is about confronting something that will change how you see your place in existence. We're going to start simple. We're going to start with your eyes and the night sky and those 3,000 visible stars, and then we're going to zoom out and out and out. Each time we zoom out, you're going to think we've reached the end. You're going to think, okay, now I know the real number. And each time you'll be wrong. Each time we'll zoom out again and the number will explode into something even more impossible. By the end of this, you won't just know how many stars exist in the universe. You'll understand why that number is beyond comprehension. You'll understand why beyond comprehension isn't dramatic language or poetic exaggeration. It's the literal truth. The number of stars in the universe is beyond the human capacity to comprehend, and yet we've measured it. We've calculated it. We know it. That's the beautiful horror of modern astronomy. We can count things that cannot be counted. We can measure scales that dwarf measurement itself. Let me show you. What you see is a lie, those 3,000 stars you can see on a perfect night. Every single one of them is in our neighborhood, our galaxy. The Milky Way, not a single star you see with your naked eye is outside our home galaxy. Not one. When you look up at the night sky, you're not seeing the universe. You're seeing the inside of our galactic living room. And here's the thing that should make your stomach drop. The Milky Way galaxy contains between 100 billion and 400 billion stars. Let me write that out so you can see it. 100,000,000,000 stars. That's the minimum estimate. Some calculations push it to 400,000,000,000,000. Let's be conservative and stick with 100 billion. You saw 3,000,000 stars. Out of 100,000,000,000,000 stars in your own galaxy, you're seeing 3,000. Do the math. You're seeing 0.00003% of your own galaxy, 3/millionths of 1%. It's not that you're seeing a small fraction. You're seeing essentially nothing. You're seeing a rounding error. Imagine you're trying to understand Earth's population by looking at 3 people. That's what you're doing when you look at the night sky and think you're seeing the galaxy. The Milky Way is massive. Genuinely, incomprehensibly massive. It's roughly 100,000 light years across. Light, traveling at 186,000 miles per second, so fast it could circle Earth 7.5 times in 1 second, takes 100,000 years to cross our galaxy. 100,000 years at the fastest speed possible in the universe. And every single point in that massive disk, stars, hundreds of billions of them. Red dwarfs smaller than our sun. Blue giants dozens of times larger. Binary star systems orbiting each other. Triple star systems, stars being born in stellar nurseries. Stars dying in supernova explosions. Stars that have already lived and died before their light ever reaches us. The galaxy is packed with them, dense with them, absolutely stuffed with stars in a way that the night sky never reveals to you. Why can't you see them? Distance. Just distance. Most stars in our galaxy are so far away that their light is too faint to reach your eyes with enough intensity to trigger your retina. Your eyes are remarkable instruments, but they have limits. They can only detect light above a certain threshold. Everything dimmer than that threshold, invisible. And most of the galaxy is exactly that dim when viewed from Earth. The stars are there, billions and billions of them, but they're too far away for you to see. Here's another thing that should blow your mind, that fuzzy band of light you see stretching across the sky on a dark night, the thing we call the Milky Way. That's not individual stars. That's the combined light of millions of stars too far away to see separately. You're looking at our galaxy edge-on, seeing the accumulated glow of countless distant suns. Each point of light in that band represents thousands or millions of stars your eyes can't separate. Okay, you say, I get it. 100 billion stars in the Milky Way, that's huge. That's the answer. That's how many stars exist. You're thinking we're done. You're thinking you now know the scale of the universe. You think 100 billion is the incomprehensible number I promised. Wrong. Completely wrong. That's how many stars exist in one galaxy. One single galaxy, ours, the galaxy we happen to live in. And here's what's going to destroy your sense of scale. Our galaxy isn't special. It's not unique. It's not the center of anything. It's not even particularly large. The Milky Way is a medium-sized spiral galaxy. There are bigger ones, lots of bigger ones. The Andromeda Galaxy, our nearest large neighbor, contains roughly 1 trillion stars, 10 times more than the Milky Way, but that's still thinking too small. We're not talking about one other galaxy. We're not talking about a handful of nearby galaxies. We're talking about something so much larger that 100 billion stars becomes a trivial number. An insignificant fraction, a single data point in a calculation so vast it makes our entire galaxy look like a speck of dust. Because the Milky Way isn't alone. It's not one of a few galaxies, it's one of many galaxies. And when I say many, I need you to understand I'm using that word in a way that completely breaks its normal meaning. We're not talking about dozens of galaxies, not hundreds, not thousands, not even millions. The number is so much larger than that. The number is so large that you're going to read it in the next section, and your brain is going to refuse to process it. Your brain is going to read the number, acknowledge it, and then immediately scale it back down to something manageable because the real number is simply too big to hold. This is where the journey stops being about facts and starts being about confronting the limits of human comprehension. This is where we stop counting and start dealing with something closer to infinity. The Hubble shock. We're not alone in 1924, everything changed. Everything you thought you knew about the universe became obsolete in a single observation. Edwin Hubble, working at the Mount Wilson Observatory with the most powerful telescope that existed at the time, pointed his instrument at a fuzzy patch of light in the night sky called Andromeda. For years, decades actually, astronomers had been arguing about what these fuzzy objects were. They called them nebulae. Some thought they were clouds of gas within our own galaxy. Others suspected something more radical but couldn't prove it. Hubble proved it. He identified individual stars within Andromeda, specifically Cepheids variable stars, which pulse at predictable rates based on their luminosity. By measuring how bright these stars appeared versus how bright they should be, he calculated the distance. Andromeda wasn't a cloud of gas in our galaxy. It was another galaxy, an entire separate island of hundreds of billions of stars, and it was 5 million light-years away. Let that sink in. 5 million light-years. Light takes 5 million years to travel from Andromeda to Earth. When you look at Andromeda, when you see that fuzzy smudge in the sky, you're looking 5 million years into the past. You're seeing Andromeda as it was before humans existed, before our ancestors came down from the trees, before the ice ages. The light that hits your eyes tonight left Andromeda when our species was still millions of years away from evolving. The Milky Way wasn't the universe. It was just one galaxy among many. How many? In 1924, nobody knew, but if there was one other galaxy, there had to be more. The question became, how many more? For decades, astronomers counted galaxies. Every time they built a bigger telescope, they found more. Hundreds of galaxies became thousands. Thousands became millions. But we didn't truly understand the scale until 1995, when astronomers did something that seemed almost pointless. They pointed the Hubble Space Telescope at a tiny, dark patch of sky, not a patch with interesting objects, not a patch with visible stars or galaxies, an empty patch, a spot that looked completely black and boring, a space the size of a grain of sand held at arm's length. They left the camera open for 10 days. For 10 days, the telescope stared at this apparently empty patch of darkness, collecting every single photon of light that drifted in. They were essentially taking the longest exposure photograph ever attempted, gathering light so faint that no human eye could ever detect it, light from objects so distant that they were invisible to every previous telescope ever built. What came back broke their minds. That empty patch of sky contained 3000 galaxies, not stars, galaxies. Entire galaxies, each containing billions of stars, crammed into a space the size of a grain of sand held at arm's length. 3,000 separate island universes, each one comparable to or larger than the Milky Way, each one containing 100 billion stars, all packed into what looked like empty darkness. They called it the Hubble Deep Field, and it changed everything. Because here's what it meant. If a random empty patch of sky contains 3000 galaxies, then the entire sky must be packed with them. They pointed the telescope at other empty patches. Same result. Thousands of galaxies everywhere they looked. The universe wasn't mostly empty with a few galaxies scattered around. The universe was absolutely stuffed with galaxies, packed with them, dense with them. Everywhere you looked, or more accurately, everywhere you looked hard enough, you found thousands of galaxies. The math became simple and horrifying. The entire sky contains about 41,253 square degrees. The Hubble Deep Field covered 0.0000026 square degrees. If that tiny fraction contained 3000 galaxies, and that ratio held across the entire sky, then the total number of galaxies was enormous, incomprehensible. The estimates started coming in. 50 billion galaxies, 100 billion galaxies. In 2016, new analysis pushed it even higher. 2 trillion galaxies. 2 trillion galaxies. Let me write that out. 2,000,000,000,000,000 galaxies, each one containing, on average, 100 billion stars. The multiplication is simple. The result is not. 2 trillion times 100 billion equals something your brain cannot hold, something that exists only as an abstraction, a number so large that it has no referent in human experience. The universe wasn't mostly empty. It was packed with galaxies, and those galaxies were packed with stars. The emptiness you see when you look at the night sky isn't real. It's an illusion caused by distance and the limitations of your eyes. The darkness is full, the void is crowded. Every empty space, when examined closely enough, reveals itself to be teeming with galaxies, with light. With stars, with worlds, the universe is not sparse, it's not lonely. It's overwhelming in its abundance, it's suffocating in its density, and this is just what we can see, just the observable universe, just the part where light has had time to reach us. Beyond that boundary, more galaxies, more stars, possibly infinite more. The counting doesn't stop, it never stops. The universe just keeps going, keeps expanding, keeps filling itself with more structure, more complexity, more stars than any human mind will ever be able to comprehend. That's the shock. That's the revelation. We're not alone. We're surrounded, drowning in it, buried under numbers so large they lose meaning. The multiplication that destroys your brain, here's where the numbers stop making sense. Here's where your brain gives up and just accepts symbols on a page without really processing what they mean. Because we're about to do some multiplication. Simple multiplication. The kind you learned in elementary school. But the result is going to break something inside your understanding of scale. Current estimates say there are 200 billion galaxies in the observable universe. Some scientists, based on newer data from deeper observations, say 2 trillion galaxies. That's 10 times more. But let's be conservative. Let's use the lower estimate. Let's say 200 billion galaxies. That's 200,000,000,000 galaxies. 200,000 million galaxies, each one a massive structure containing billions of stars, each one comparable to or larger than our Milky Way, each one an island universe separated from its neighbors by millions of light years of mostly empty space. Each galaxy contains an average of 100 billion stars. We know this from observations. We can measure the mass of galaxies. We can count stars in nearby galaxies where we can resolve individual points of light. We can estimate based on the total luminosity of distant galaxies. The average comes out to about 100 billion stars per galaxy. Some galaxies are smaller. Dwarf galaxies might contain only a few billion stars. Some are larger. Giant elliptical galaxies can contain trillions of stars. But the average, across all galaxy types, is approximately 100 billion. That's 100,000,000,000,000 stars per galaxy. Now multiply them. This is just math. Simple arithmetic. Two numbers multiplied together. 200,000,000,000,000 galaxies times 100,000,000,000,000 stars per galaxy. Let's do it. 200,000,000,000,000 times 100,000,000,000,000 equals 20,000,000,000,000,000,000,000,000,000,000,000. That's the answer. That's how many stars exist in the observable universe. That's 20 billion trillion stars, written out with all the zeros. 20,000,000,000,000,000,000,000,000,000,000,000 stars. In scientific notation, which is the only sane way to write numbers this large, 2 times 10 to stars. That's a 2 with 22 zeros after it. Your brain just read that number. Your eyes processed it, but you didn't really understand it. You can't understand it. Nobody can. The human brain didn't evolve to comprehend numbers like this. We evolved to count small groups. How many people are in my tribe? How many apples are on this tree? How many predators are circling our camp? We can handle dozens. We can stretch to hundreds. Thousands require abstraction. Millions require serious mental effort. But billions, trillions, numbers with 22 digits, these aren't numbers anymore. They're hieroglyphics, symbols that represent something beyond comprehension. Let me try to make this real for you. Let's say you decide to count all the stars in the universe. You're immortal now, congratulations, and you have unlimited time. You're going to count them one by one, 1 star per second. That's pretty fast. That's faster than you can actually count out loud, but let's say you can do it. 1 Mississippi, 1 star, 2 Mississippi, 2 stars. You keep going, no breaks, no sleep, no stopping, just counting. 1 star every single second. How long would it take you to count to 20? 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. 634 billion years. 634 billion years of constant counting. 1 number per second, never stopping, never slowing down, just counting and counting and counting for 634, 0, 0, 0, 0, 0, 0, 0, 0, 0 years. The universe is only 13.8 billion years old. The entire universe from the Big Bang to right now has only existed for 13.8 billion years. You'd need to count for 634 billion years. You'd need 46 complete lifetimes of the universe to finish counting the stars. Start counting at the Big Bang. Count through the formation of the first stars. Count through the birth of galaxies. Count through the formation of our solar system. Count through the entire history of Earth. Count through the dinosaurs. Count through human evolution. Count through all of human history. Count until now. You've been counting for 13.8 billion years and you've counted about 435 trillion stars. You have 19,999,565,000,000,000,000,000,000 stars left to count. You've barely started. You haven't even made a dent. You've counted 0.00002% of the total. Start the universe over. Big Bang again. Count through another 13.8 billion years. Do it again and again and again. 46 complete cycles of the universe from Big Bang to heat death just to count the stars once. That's the scale we're dealing with. That's what 2 times 10 to means. It's not just a big number. It's a number that dwarfs time itself. It's a number that makes the age of the universe look small. The universe has existed for 13.8 billion years, an incomprehensibly long time by human standards, and it's not old enough to count its own stars, not even close. And here's the thing that should really mess with your head. This number is precise. This isn't a guess. This isn't a rough estimate or a wild speculation. This is calculated from actual observations. We counted galaxies in small patches of sky. We measured their distances. We estimated their stellar populations. We did the statistics. We accounted for the galaxies too faint or too distant to see. We ran the numbers through peer review. Multiple independent teams using different methods arrived at similar results. The number is real. 20,000,000,000,000,000,000,000,000,000 stars. That's the minimum number of stars in the observable universe. It could be higher if the 2 trillion galaxy estimate is correct. Multiply that number by 10. But it's not lower. It can't be lower. We've counted too carefully. We've measured too precisely. The number is locked in. The universe contains at least 20 billion trillion stars and probably significantly more. Think about what that means. Think about the physical reality this represents. Each one of those stars is a massive ball of nuclear fusion. Each one is converting hydrogen to helium, releasing energy, burning for billions of years. Each one has a gravitational field. Many have planets. Some of those planets are inhabitable zones where liquid water could exist. Some of those planets probably have life. Some of that life is probably intelligent. And there are 20,000,000,000,000,000,000,000,000,000,000,000,000,000,000 of these stars. The universe isn't just big, it's prolific. It's abundant beyond all reasonable limits. It's wasteful in its creativity. It makes stars the way Earth makes grains of sand, casually, carelessly, in numbers too large to track. And you're standing on a planet orbiting one of them. One single star among 20 billion trillion. Your entire civilization, every human who has ever lived, every thought ever thought, every work of art ever created, every war ever fought, all of it happened on a small rocky planet orbiting one unremarkable star in the outer suburbs of one medium-sized galaxy among 200 billion galaxies. You're not just small, you're cosmically negligible, statistically irrelevant, a rounding error in the census of existence. But you counted the stars anyway. That's the miracle. That's the thing that makes this more than just depressing. Humanity figured this out. We built the telescopes. We developed the math. We measured the distances. We counted the galaxies. We did the multiplication. We stared into incomprehensible vastness and we quantified it. We gave it a number. An actual, precise, defensible number. We're tiny, but we're not ignorant. We're insignificant, but we're not blind. That has to count for something. The comparison that makes it click, numbers that big don't mean anything to your brain. You read 20 billion trillion and your eyes glaze over. It's too abstract, too removed from anything in your experience. You need something concrete, something you can touch, something that connects this cosmic scale to human reality. So let's compare it to something you actually understand. Go to a beach, any beach, stick your hand in the sand, scoop up a handful, look at what you're holding. Thousands of tiny grains, each one a fragment of rock worn down by millions of years of wave action. Count them if you want. You'll get bored before you finish, but there are probably several thousand grains in your palm. Now think about the entire beach. All the sand stretching along the shoreline. Think about all the beaches on Earth. Every coastline, every sandy shore, every beach on every continent and island. How many grains of sand are there? Scientists have actually calculated this. It's not easy, you can't count them individually, but you can estimate based on the volume of sand and the average size of grains. The number is approximately 5 trillion grains of sand on all the beaches on Earth. That's 7,500,000,000,000 grains. Every beach everywhere. Every grain counted. 7.5 trillion grains of sand on Earth. 20 billion trillion stars in the universe. Do the division.
20,000,000,000,000,000,000,000,000,000
divided by 7,500,000,000,000,000 equals approximately 666. Round it to make it cleaner. There are roughly 7 million stars in the universe for every grain of sand on every beach on Earth. Actually, let me recalculate that more carefully. The number is closer to 10,000 stars per grain of sand when you account for more recent estimates of both sand grains and stars. Let's use that number because it's more conservative and easier to visualize. There are roughly 10,000 stars in the universe for every single grain of sand on every beach on Earth. Think about that. Really think about it. Go back to that beach. Pick up another handful of sand. Look at those tiny grains, each one smaller than the head of a pin. Each one practically invisible individually. You're holding thousands of them. Now multiply each grain by 10,000. For every single grain of sand in your hand, there are 10,000 stars burning in space. Drop the sand. Walk along the beach. Every step you take crushes thousands of grains. Each one represents 10,000 stars. The entire beach, all that sand stretching into the distance, represents trillions of stars, and there are beaches all over the world. Walk the entire coastline of California. Every grain of sand you pass represents 10,000 stars. Fly to Australia. Walk every beach on the continent. Every grain 10,000 stars. Visit every island in the Pacific, every shore in Indonesia, every beach in the Caribbean, the Mediterranean, the North Sea, Antarctica. Every coastline on Earth. Count every grain of sand and multiply by 10,000. That's how many stars exist. This comparison works because sand is already numerous beyond easy counting. You can't count all the sand on a single beach, let alone all beaches on Earth. It's too much. Too many individual pieces, but you can understand sand. You can hold it. You can see it. You can pour it through your fingers and watch it scatter. And when I tell you there are 10,000 stars for every grain, 10,000 massive nuclear furnaces, each one potentially surrounded by planets, each one burning for billions of years, you can begin to grasp the scale. But let's push it further. Let's make it even more concrete. A single grain of sand weighs about 0.0044 grams. All the sand on all Earth's beaches weighs about 33 trillion kilograms. Now think about a star. Our sun weighs approximately 2 times 10³ kilograms. That's 2,000,000,000,000,000,000,000,000,000,000,000,000,000,000 kilograms. The mass of one star is about 60 quintillion times the mass of all the sand on Earth, and there are 20 billion trillion stars. The total mass of all stars in the universe is incomprehensibly larger than all the sand on Earth. It's not even close. It's not even a comparison. The universe could lose all the matter in Earth, turn it into pure energy and radiate it away, and it wouldn't notice. We're not just small. We're negligible even when compared to the negligible. Here's another comparison. There are approximately 100 billion neurons in a human brain. That's 100,000,000,000,000 neurons. Each neuron can connect to thousands of other neurons, creating about 100 trillion neural connections. Your brain, this thing reading these words right now, contains about 100 trillion connections. That's roughly the same as the number of stars in 5,000 galaxies. Your brain's complexity approaches galactic scales, but the universe contains 200 billion galaxies. The total number of stars is 2,000 times larger than the number of neural connections in all the human brains that have ever existed in all of human history combined. Or try this. There are about 37 trillion cells in the human body. The universe contains about 540,000 times more stars than your body contains cells. Every cell in your body, if it represented a star, would represent just a tiny fraction of one galaxy. You'd need 540,000 people, a decent-sized city, to have enough collective cells to represent all the stars in the universe. The comparisons keep failing. They keep falling short. Because everything we compare to sand, neurons, cells, atoms in our body, everything is too small. The universe has more stars than we have anything countable to compare them to. We run out of concrete comparisons. We run out of tangible objects. We're forced back to abstractions, to scientific notation, to numbers that exist only as concepts. And yet the stars are real. They're not abstract. Each one is a physical object, massive, hot, real, burning in actual space. They exist right now. While you read this, 20 billion trillion stars are fusing hydrogen into helium, releasing energy, warming planets, creating the conditions for chemistry and maybe life. They're real. All of them. Every single one. The number isn't speculation. It's census data from the universe itself. And that's just what we can see. Here's the truly disturbing part, the part that should keep you awake at night. Those 20 billion trillion stars, that's just the observable universe. Just the part we can see. Just the bubble of space where light has had enough time to reach us since the Big Bang. The observable universe is a sphere centered on Earth. It extends about 5 billion light-years in every direction. Why 46? 5 billion light-years when the universe is only 8 billion years old. Because space itself has been expanding while light traveled toward us. A photon that left a distant galaxy 8 billion years ago has been traveling for 8 billion years, but in that time, the galaxy it came from has been carried away by cosmic expansion. That galaxy is now about 5 billion light-years away. The observable universe is therefore about 93 billion light-years across. That's the size of our visible bubble. But the universe doesn't stop there. The actual universe, the whole universe, is almost certainly much, much bigger. The current leading cosmological models suggest the universe might be infinite. Actually infinite. Not really big infinite. Not so big it might as well be infinite. Actually infinite, extending forever in all directions. Never ending. No edge, no boundary, just more space, more galaxies, more stars, continuing without limit. We don't know for sure if it's infinite. We can't know. We can only see as far as light has had time to travel. Beyond that boundary, beyond the edge of our observable bubble, we have no data, no observations, no measurements. It's not that the light is too faint or the objects too distant for our telescopes. It's that light from those regions literally has not had time to reach us yet. The universe is only 8 billion years old. Light from anything farther than 5 billion light-years away hasn't reached us yet. It's still in transit, or it never will reach us because cosmic expansion is carrying those regions away faster than light can cross the intervening space. So what's out there? Beyond the edge of what we can see, more galaxies, more stars, certainly billions of trillions more, possibly infinite more. If the universe is infinite, then there are infinite galaxies and infinite stars. The number 20 billion trillion becomes meaningless. It's just the count within our local bubble. The actual total is undefined, uncountable, literally infinite. Even if the universe isn't infinite, even if it's merely enormous but finite, it's almost certainly much larger than the observable portion. Conservative estimates based on cosmic inflation theory suggest the entire universe is at least 250 times larger than the observable universe in each direction. That means the volume is 253 equals 15, 625, 000 times larger than what we can see. If we're seeing 200 billion galaxies in our observable bubble, and the full universe is 15 million times larger, then there are about 3 times 10 total galaxies. That's 3,000,000,000,000,000,000,000,000 galaxies. 3 quintillion galaxies, each containing an average of 100 billion stars. The total number of stars in the full universe would be about 3 times 10 2 stars. That's 300, 000, 000, 000, 000, 000, 000, 000, 000, 000, 000, 000 stars. Compare that to our 20 billion trillion. Our observable count is 0.0000067% of the full universe under this model. We're counting stars in our little bubble of visibility and calling it the universe. It's like standing in your house, counting the furniture, couch, table, 4 chairs, bed, 6 total items, and then claiming you've counted everything that exists on Earth. You've counted your house. You haven't counted the neighborhood. You haven't counted the city. You haven't even begun to count the world. The real number of stars, we don't know. We can't know. We can only count what we can see, and what we can see is determined by the age of the universe and the speed of light. Every second, the observable universe grows slightly larger as light from more distant regions reaches us for the first time. Every second, the census increases, but we'll never see it all. Cosmic expansion guarantees that some regions are receding faster than light can catch up. Those regions are forever beyond our view. Their stars will never be counted. 20 billion trillion is the minimum, the absolute, confirmed, measured minimum. It only goes up from there. The actual number might be 10 times larger. 100 times larger, 1,000,000 times larger, infinite. We don't know. We're counting what we can see and acknowledging with appropriate humility that we're probably missing most of it. And this is where the numbers stop being abstract and start becoming philosophical. Because if there are infinite stars, and there might be, then everything possible happens somewhere. Every planet configuration, every chemical combination, every possible arrangement of matter, including you. If the universe is infinite, there are infinite copies of you scattered across infinite space, reading infinite copies of this exact text, having this exact same existential crisis simultaneously. The numbers become so large that probability guarantees duplication. Uniqueness becomes impossible. But even if the universe is finite, even if we stick with the conservative 20 billion trillion stars in the observable universe, we're still dealing with numbers that dwarf comprehension. We're still cosmic specks orbiting an unremarkable star in a sea of stars so numerous that counting them takes longer than the universe has existed. We're still impossibly small, and the cosmos is still impossibly vast, and the gap between those scales is measured in numbers that break our brains when we try to hold them. Why this number keeps growing every time we build a better telescope, we find more galaxies. Every single time, without exception. This has been the pattern for nearly a century now, and it shows no signs of stopping. The history of astronomy is a history of being consistently wrong about scale. Every generation of astronomers thinks they've finally seen everything, finally counted all the galaxies, finally understood the full scope of the universe, and every generation is proven wrong by the next one with better instruments. In the 1980s, based on the best telescopes available at the time, astronomers estimated there were maybe 100 billion galaxies in the observable universe. This wasn't a guess. This was based on careful observations, statistical analysis, surveys of large portions of the sky. They counted galaxies in representative regions, measured how many appeared at different distances, and extrapolated to the full sky. The math was solid. The methodology was sound. 100 billion galaxies. That was the number that appeared in textbooks, in scientific papers, in popular science writing. That was what humanity believed about the universe. Then we built the Hubble Space Telescope. Launched in 1990, placed in orbit above Earth's atmosphere to avoid the blurring and distortion that atmosphere causes, Hubble was the most powerful optical telescope ever created. It could see fainter objects, resolve finer details, look deeper into space than any telescope before it. And immediately the count started changing. Hubble could see galaxies that ground-based telescopes missed, fainter galaxies, more distant galaxies, galaxies hiding in what looked like empty space. The astronomers went back and did the counts again with Hubble data. They surveyed the same patches of sky that had been surveyed before, but now with better instruments. And the number jumped, not by a little, by double. The new estimate was 200 billion galaxies, twice what we thought. Overnight, the universe doubled in size. All those textbooks were wrong. All those estimates were wrong. We'd been undercounting by half, but it didn't stop there. Because Hubble kept observing, kept collecting data, kept looking at fainter and more distant objects. And in 2016, a team of astronomers led by Christopher Consellis did something clever. They didn't just count the galaxies Hubble could see. They used mathematical models to estimate how many galaxies were too faint or too distant for even Hubble to detect. They looked at how galaxy numbers increased with each improvement in telescope sensitivity. They extrapolated the pattern. They accounted for the galaxies that must exist, but that we simply can't see yet. Their conclusion: 2 trillion galaxies. 2 trillion, not 200 billion, 10 times more than the previous estimate. The number that had been in textbooks for 2 decades was off by a factor of 10. We weren't just slightly wrong, we were catastrophically wrong. The universe contained 10 times more galaxies than we thought, which meant 10 times more stars, which meant the total stellar population was around 200 billion trillion instead of 20 billion trillion. And now we have the James Webb Space Telescope. Launched on Christmas Day 2021, JWST is the largest and most powerful space telescope ever built. Its mirror is 5 meters across compared to Hubble's 4 meters. It observes in infrared wavelengths, allowing it to see through cosmic dust and detect the most distant galaxies whose light has been stretched into the infrared by cosmic expansion. It can look deeper into space, further back in time than any previous instrument. And it's finding galaxies we didn't know existed. Ancient galaxies from the early universe, from just a few 100 million years after the Big Bang. Galaxies that formed when the universe was only 2% of its current age. Galaxies that shouldn't exist according to our models of galaxy formation. They're too massive, too well-developed, too mature for their age. Every image JWST returns reveals more surprises, more galaxies in supposedly empty space, more structure at early times, more complexity than our theories predicted. The count keeps climbing. Every new observation adds to the census. And here's the thing that should blow your mind. We're not finding a few more galaxies. We're not fine-tuning the count by a few percent. We're discovering that entire categories of galaxies were invisible to us. Faint dwarf galaxies that exist in huge numbers but were too dim to detect. Ultra-diffuse galaxies spread out over large volumes of space. High redshift galaxies so distant their light has been stretched beyond what Hubble could see. Every time we look with better instruments, we find populations of galaxies we didn't know were there. This pattern has held for 100 years. In the 1920s, we thought there was one galaxy, the Milky Way. Then Hubble discovered Andromeda and we realized there were multiple galaxies. In the 1930s and 1940s, we thought there were thousands. By the 1960s, we knew there were millions. In the 1980s, we estimated billions. In the 1990s, we said 100 billion. In 2016, we revised to 2 trillion. And now, with JWST, we're finding evidence that even 2 trillion might be an undercount. We thought we knew the scale. We were wrong. We're always wrong. The universe is always bigger than we think, always more complex, always more populated. Every time we push the boundaries of observation, the universe pushes back and reveals more structure, more galaxies, more stars, more stuff than we thought could possibly be there. And this isn't because we're bad at astronomy. This isn't because we're making mistakes or using flawed methods. It's because the universe is genuinely hard to see. Most galaxies are faint. Most are distant. Most are hidden behind dust or obscured by brighter foreground objects. We're trying to count objects scattered across billions of light years of space using instruments that can only collect a tiny amount of light. It's like trying to count all the houses in a city at night from an airplane, but you can only see the ones with lights on, and your eyes can only detect lights brighter than a certain threshold, and there's fog everywhere. You count what you can see and you make educated guesses about what you're missing. And every time you get better eyes or clearer weather, you find more houses. The number keeps growing because we keep looking harder. Because we keep building better telescopes, because we keep pushing the limits of technology and observation. And there's no reason to think we've reached the end. JWST will operate for at least a decade, probably longer. It will keep finding more galaxies. Future telescopes will find even more. Ground-based telescopes with adaptive optics and interferometry will probe different wavelengths and different types of objects. Space telescopes larger than JWST are being planned. The count will keep climbing. How high will it go? We don't know. Maybe the 2 trillion estimate is close to correct and we're just filling in details now. Maybe it's still an undercount by a factor of 2 or 3 or 10. Maybe there are types of galaxies we haven't even imagined yet, dark galaxies or ultra-faint galaxies or galaxies made of exotic matter that don't emit light in wavelengths we're looking at. The universe has surprised us before. It'll surprise us again. What we know for certain is this: Every time we've thought we understood the scale of the cosmos, we've been humbled. Every time we've drawn a line and said, this is how big the universe is, the universe has shown us we drew the line too small. The pattern is consistent. The universe is bigger than we think. Always. The number of stars keeps growing, and it'll keep growing until we finally have instruments powerful enough to see everything there is to see, if such instruments are even possible. The number that breaks meaning, so how many stars exist in the universe? After everything we've discussed, after all the observations and calculations and revisions, what's the answer? At minimum, 20,000,000,000,000,000,000,000,000,000,000 stars in the observable universe alone. 20 billion trillion stars. This is the conservative estimate based on 200 billion galaxies with an average of 100 billion stars each. This number is solid. It's based on actual galaxy counts from Hubble and other telescopes. It's peer-reviewed. It's confirmed by multiple independent research groups using different methodologies. This is the floor. The universe contains at least this many stars. More likely, several times that number, possibly 200 billion trillion stars if the 2 trillion galaxy estimate is correct. That would be 200,000,000,000,000,000,000,000,000,000,000,000,000 stars. 200 billion trillion. 10 times the conservative estimate. This is based on more recent analysis that accounts for galaxies too faint for current telescopes to detect. It's less certain than the 20 billion trillion number, but it's probably closer to the truth. The universe likely contains somewhere between 20 and 200 billion trillion stars in the observable portion alone. Actually, probably infinite or so close to infinite that the distinction doesn't matter, because the observable universe isn't the whole universe. It's just the part we can see, limited by the speed of light and the age of the universe. The full universe is almost certainly much larger, possibly infinitely larger. If it's infinite, then there are infinite galaxies and infinite stars. The numbers we've been discussing, 20 billion trillion, 200 billion trillion, are just the count in our local bubble of visibility. The true total might be literally uncountable. This is not a metaphor. This is not exaggeration. This is not poetic language or dramatic flourish. This is measured, confirmed, scientific reality. We have photographs of thousands of galaxies in tiny patches of sky. We have spectroscopic data showing their distances. We have statistical models accounting for selection effects and observational biases. The numbers are real. The stars are real. All 20 billion trillion of them, minimum, are actually out there right now, burning hydrogen, emitting light, heating planets, creating the conditions for chemistry and life. The universe contains more stars than your brain can process, more stars than you can imagine, more stars than you can visualize or comprehend or hold in your mind as anything other than an abstract number. There are more stars in the universe than there are moments in the entire history of human civilization. If every human who ever lived, roughly 100 billion people across all of history, spent their entire life counting stars at one per second, working together, never sleeping, we'd count about 300 quintillion stars total. That's 0.00015% of the stars in the observable universe. We wouldn't even make a dent. And here's the beautiful, terrifying truth that makes all of this personally relevant. We live on a planet orbiting just one of those stars. One ordinary, medium-sized star in one ordinary galaxy among 200 billion galaxies. Our sun is spectral class G2V, a yellow dwarf star with a mass of about 1 solar mass, because we literally define the unit based on our sun. It's not the biggest star. It's not the smallest. It's not the hottest or the coolest or the brightest or the dimmest. It's average, unremarkable. The kind of star you'd skip over if you were doing a galactic survey because there's nothing particularly interesting about it. And we orbit this average star on a small, rocky planet, the third one out from the sun, in a solar system that contains 8 planets total, or 9 if you're still bitter about Pluto. Earth is the only planet in our solar system with life, as far as we know. It might be the only planet with life in our entire galaxy, though statistically that seems unlikely. But even if every star in the Milky Way had a planet with intelligent life, we'd still be one civilization among 100 billion. And the Milky Way is one galaxy among 200 billion. We are cosmically insignificant. This isn't self-deprecation. This isn't pessimism. This is mathematical fact. Our entire species, our entire history, our wars and art and science and religion and politics and loves and losses, all of it happens on a dust speck orbiting one star among 20 billion trillion stars. Earth is 742 kilometers in diameter. The observable universe is 93 billion light-years across. 1 light-year is 46 trillion kilometers. Do the math. Earth is 0.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000% of the diameter of the observable universe. We are a rounding error. We are noise in the cosmic census. Every human achievement happens on this tiny world. Every person you've ever known, everyone you've loved, everyone you've hated, every stranger you've passed on the street. All of us live on this one small planet. All of human drama, all our conflicts and collaborations, all our discoveries and disasters, confined to one world among uncountable billions. Carl Sagan called Earth a pale blue dot after Voyager 1 photographed it from 6 billion kilometers away. From that distance, Earth was less than a pixel, a tiny point of light in the vastness. And that photograph was taken from within our own solar system. From another galaxy, Earth would be completely invisible, utterly undetectable, lost in the glare of our sun. We are nothing, cosmically, objectively, mathematically nothing. And yet we figured this out. We built the telescopes, we developed the mathematics, we observed the galaxies, we measured the distances, we counted the stars, we did the multiplication. We came up with the number 20,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,000,0 know how many stars there are. We, the insignificant specks on the dust speck, measured the cosmos. We're tiny. We're irrelevant. We're lost in a universe so large that our entire civilization wouldn't be noticed if it vanished tomorrow, but we're not ignorant. We're not blind. We looked up at the night sky and we didn't just wonder about those points of light. We measured them. We figured out what they were, how far away they were, how many there were. We mapped the universe. We counted its contents. We understand, at least partially, the structure and scale of reality itself. That's the real miracle here. Not the number of stars, though that number is staggering and beautiful and terrifying in its immensity. The miracle is that we can count them at all. The miracle is that the universe made consciousness, made intelligence, made curious beings capable of building instruments and doing mathematics and figuring out truths about reality that are not obvious, that require effort and ingenuity and centuries of cumulative scientific progress to discover. The universe is vast and we are small, but smallness is not the same as meaninglessness. We matter because we understand. We matter because we looked at incomprehensible immensity and we comprehended it anyway. We found the number. 20 billion trillion stars minimum and climbing. That's the answer. And the fact that we know the answer, that's what makes us significant.